All right, so on page 24, we're going to superimpose a box plot on top of a normal model, so a standard normal curve. Okay, so let's go ahead and start with that. We know that a standard normal curve has, of course, our mean is 0. I want you to go ahead and put the standard deviations on here, 1, 2, 3, -1, -2, -3. Now, while you're doing that, I wanted to talk to you about in the business model, in the business world, a lot of managers or employees have their people that work in the company go through a program called Six Sigma. And I know my dad did that even as an engineer. Why do you think that program is called Six Sigma? Good, because there are 6 standard deviations across the normal model. And so, for example, if you are in production and you want to follow the Six Sigma method, I mean, it's a lot more complex than just this concept, but you want to have the correct items 99.7% of time, okay, because that's what you got going on within the 3 to 3. Okay, but anyway, so that's 6 sigmas. So think about 6 standard deviations across the normal model. All right, so let's put our standard normal curve on. Where is the median always going to be when it's symmetrical? Good, where the mean is. So our median will always be right here where the mean is. All right, good. Next, I want you to think about where on this curve Q1 and Q3 are going to be. Not exactly, but, in what vicinity are Q1 and Q3 going to be located? Good, very good. So Thomas said in between -1 and +1 standard deviations. Okay, why? Good, because the box contains the middle, what? 50%. And the box contains the middle 50%, and we know from -1 to +1 there's 68%, so we know that our box needs to be contained in there, okay? Well, let's find out specifically where. I want to know exactly what z-score Q1 has. Okay, I want to know what is the z-score for Q1. How can I find that out? Can I do x minus the mean over the standard deviation? Can I do that? No. What could I do? Aha! Inverse norm of the area below is the z at that spot. What percentage is below Q1? 25%. Always. So that means inverse norm of 0.25 is going to be the z-score of Q1 always. Okay? And if you went and put that in, that is -0.6745. So we are about 2/3 of the way to -1. So here's about -0.6745. Okay, that's Q1. All right, so what can you tell me about the z-score for Q3? Because of the symmetry, it is the positive 0.6745. Okay, and that is always, because that doesn't change. It is always at the 75th percentile. So my Q3 is going to be located about right there. So my box is there in between 1 standard deviation down and 1 standard deviation up. Okay. It spans that. And then the whiskers, those kind of depend on how far your data goes out. So I'm just going to kind of stick those out there. I don't really know specifics on your whiskers. Okay, but they should be going out there. All right, let's go on to number 1. Here we go. John Bill of Stanford, California, recorded the speeds of cars driving past his house, where the speed limit read 20 miles per hour. The average of 100 readings was 23.84 miles per hour. So I know my X bar is 23.84 with a standard deviation of 3.56. Now, I tell you to draw and label the normal model, but that's kind of boring, and we know how to do that and stuff, so I put this new problem in there, which you don't actually have on your paper, so I added this new question this morning, because I like this better. I want to know what proportion of people speed past his house. Okay? So, in order to be speeding, yes. Okay, so mean is written like this. That is if you have that's the mean of the population. X bar is the mean of a sample. And since we said we had 100 readings, that to me said it's a sample, so that's why I used X bar. And likewise on the standard deviation, I used S instead of the sigma. The little sigma O thing, that would be for the population. I technically don't care at this point, okay, but it kind of, at some point I do, so I'm just kind of trying to get in the habit. I'll tell you that later. Well, I mean, at a later point, I want you to pay attention and always write if it's a mu or an X bar. I mean, so I guess we could start getting in that habit. I just know if it tells me it's a sample, then I'll do my X bar and my S. If I don't know, I kind of just put the mu and the sigma down. That's generally what I do. Okay. All right, so how do you know if they are speeding? Then they get over 20 miles per hour. Now, some people want to say X is 21, and we're not doing that. We're going to call the data value 20, because when we get the area, it'll be the area above it. So when I go get this, 20 is down here, because I know my mean is at 23.84 or something. And the area above 20. Anything above 20 is what I'm looking for. So I still use an X value of 20. Okay? So, let me give you a moment to try that one. Go for it. Okay, so I got my z-score with an X value of 20. And then I norm CDF'd to get that area from that point to infinity, so that low z-score was negative 1.08 up to 99. I hope that's the right number. I just kind of memorized that. Is that, anybody check it and see? So, what is it? Okay, so that is the percent of drivers that speed past his house. Okay, I like to put a sentence on there if it's a if it's a word problem about a scenario. Okay, so let's not just put the answer. Let's put what it is. All right, very good. So now let's kind of just tweak that a little bit and go ahead and give some of these other pieces of data for this situation. So since it is symmetrical, what can you tell me the median is? The same thing as the mean, which is, I think, 23.84. Okay, so I want you to find, let's find Q1. Let's kind of talk about it. So, I know my mean. I know my standard deviation. I want to find the speed at Q1, and I need a z-score. What is my z-score at Q1? Yeah, it's that inverse norm of 0.25 that we found out earlier is negative 0.6745. So I have my z-score, I have my mean, I have my standard deviation. Find the speed at that spot. Okay, I got 21.4 miles per hour. How about Q3? We have median already. How are we going to do Q3? Same thing, but with the different z-score. So let me let you finish that out and then find the IQR. Okay, so try that. All right, so that's what I came up with. 26.2 or 24, I think was it for the Q3, and so that makes the IQR 4.8 miles per hour. So the middle 50% are about 5, there's about a 5 miles per hour spread there. Okay, questions on that? So I want to go ahead and stop right now and let you do the next page 25 and then the warm-up on page 26 and 27. I'm going to come around and stamp you for yesterday's, and then about 10 minutes till the end of class we're going to go over last night's homework. Okay?